Have you ever stopped to think about how your phone does everything it does, or how a giant computer can now fit into a super slim laptop? It's not magic, you know. It's all about the fundamentals of electronics. In this tutorial, we're going to break it all down and give you everything you need to crush your WAEC, JAMB, and NECO physics exams.
All right, here's our game plan. We're going to start with the big question. What even is electronics? Then, we'll dive into the amazing materials that make it all happen. After that, we'll see how those materials become the building blocks of technology. And then, the fun part. We'll tackle some real exam questions. And finally, we'll wrap it all up with the key things you've got to remember. Okay, let's start right at the beginning. Before we can get into diodes and transistors and all that cool stuff, we really need to know what we're talking about. What is electronics really? So, you can think of it like this. Regular electricity, that's kind of like a big, powerful river just flowing wherever it wants. But electronics, that's where we become river engineers. We build tiny little dams and gates and channels to tell that river of electrons exactly where to go, how fast to flow, and when to stop. It's all about that precise microscopic control. Okay, so that's the big question, right? How in the world do you control something as tiny as an electron? We know some materials, like copper, are basically superhighways for them, and others, like rubber, are just a dead end. Well, the secret lies in a special class of materials that are somewhere right in the middle. And here they are, semiconductors. These materials are the absolute heart of all modern electronics. They aren't great conductors, but they aren't insulators either. They are this special in-between thing, and that's exactly what gives us the power to control the flow of electricity. This really lays it all out. Over on the left, you've got conductors like copper, an open road for electrons. On the far right, insulators like rubber, a total roadblock. And right there in the middle, you have our hero, semiconductors like silicon. They are like a road with traffic lights, giving us all the control. So the secret sauce here is something called the band gap. Just think of it like a little hurdle an electron has to jump over to get moving. In an insulator, that hurdle is like a skyscraper, way too high. In a conductor, there's no hurdle at all. But in a semiconductor, the hurdle is just the right size. We can give the electrons a little push of energy to get them over or hold them back. That's the key to everything. Now, this is where things get really genius. To get even more control, scientists use a process called doping. It's like adding a tiny pinch of a special ingredient to the mix. If you add impurities that have extra electrons, you create an N-type material. Or you can add impurities that create little empty spots called holes for electrons to jump into. That makes a P-type or positive-type material. So, what happens when you bring these two together? Well, something really cool. Those extra electrons from the N side immediately jump over to fill the empty holes on the P side. This creates a little zone right in the middle, the depletion region, that has no extra electrons and no extra holes. It becomes a natural barrier that stops the flow of electricity. And this simple barrier is the foundation for almost everything in electronics. So, we've made this amazing little barrier. Now what do we do with it? Well, this is how we build the two most important components in all of electronics: diodes and transistors. And it's actually pretty simple. A diode, that's just one of those PN junctions we just made, is basically a one-way street for electricity, Current can flow one way, but not the other. A transistor, on the other hand, is like a faucet. It's made of two p-n junctions, and it lets a tiny little current control a much, much bigger one. That's amplification. Okay, the theory is pretty cool, right? But now it's time to get practical. Let's look at some real exam questions from WAEC, JAMB, and NECO, so you can see exactly how to use this knowledge to get the right answers. All right, here's a classic question from a past WAEC exam. Just take a look. What are the key words here? For me, 3 terminal and amplify just jump off the page. Does that sound familiar based on what we just talked about? Let's break it down. We know a diode only has 2 terminals, so that's out. A transistor, though, has got 3 terminals, and its whole job is to amplify signals. It's a perfect match. The answer has to be D, transistor. See? Easy. Okay, next up, a question from JAMB. This one digs a little deeper into how that p-n junction really behaves. It's asking what happens to that barrier, that depletion region, when we apply a forward bias to get the current flowing. Just picture that depletion region as a wall. A forward bias is like pushing on that wall from both sides at the same time. And what happens when you squeeze something? It gets thinner. The wall shrinks or narrows, making it way easier for the current to get through. So the answer is A, it narrows. And for our last one, a question from NECO about a special kind of diode, the Zener diode. We know a regular diode is a one-way street, but what's the special trick this Zener diode can do? So the Zener diode is really cool. It's actually designed to work when electricity is trying to flow the wrong way. But instead of just blocking it, it holds the voltage at one super stable level, no matter what. This is called voltage regulation, and is essential for protecting delicate electronics. So the correct answer is C. We've covered a lot of ground, so let's just pause for a second and go over the key takeaways, the most important things you need to lock in for your exams. This table is basically your cheat sheet. But if you take away just one thing, let it be this. Everything, and I mean everything, starts with the controllable conductivity of semiconductors. From that one idea, we get diodes, we get transistors, and we get every single gadget you use every day. And before we finish up, here are a few pro tips to help you score every last point. First, always label your diagrams. It's easy marks. Second, remember the golden rule. Forward bias lets the current flow, reverse bias blocks it. And here's a little trick for doping. N-type has extra negative electrons. And finally, just practice drawing these circuits. The more you do it, the easier it will get. You know, when you really think about it, this core principle of amplification, of something small controlling something huge, that's the engine driving all modern technology. The journey from these basic ideas to the supercomputer in your pocket is just incredible. So next time you pick up your phone, just take a second to appreciate the amazing invisible science that makes it all work. That's it for today.
Great job following along. If you found this tutorial helpful, don't forget to subscribe to our YouTube channel for more easy-to-understand lessons. And hey, want to practice more questions and get step-by-step solutions? Visit www.examkp.com right now and keep learning smarter.